Good morning, I am Jeah Vanesse Casipong, a second-year student taking Bachelor of Science in Mathematics. Today, we will be discussing about probability distribution. We have here our objectives. At the end of the lesson, the student will be able to distinguish between discrete random variables and continuous random variables, construct a discrete probability distribution and its graph, and how to determine if a distribution is a probability distribution. Find the mean, variance, and standard deviation of a discrete probability distribution. And lastly, find the expected value of a discrete probability distribution. Random variable represents a numerical value associated with each outcome of a probability distribution, which is denoted by x. So, it is a variable x whose value is a numerical outcome of a random phenomenon. Examples: x is equal to the number of sales calls a salesperson makes in one day. X equal to the hours spent on sales calls in one day. There are two types of random variable. First is the discrete random variable. It has a finite or countable number of possible outcomes that can be listed. Example: x is equal to the number of sales calls a salesperson makes in one day. We have here our x, 0, 1, 2, 3, 4, and 5. Okay, let's move on to the second type of random variable, which is the continuous random variable. It has an uncountable number of possible outcomes represented by an interval on the number line. So this is completely the opposite of discrete random variable. Example: hours spent on sales calls in one day. So this example cannot be counted. The hours spent on sales calls in one day can be any time between 0 and 24 hours. Since in one day, there are 24 hours. Okay? Example of discrete and continuous variable. Determine whether each random variable x is discrete or continuous. Explain your reasoning. Number 1. Let x represent the number of Fortune 500 companies that lost money in the previous year. Solution: discrete random variable. Why? Because the number of companies that lost money in the previous year can be counted. So, it is discrete random variable. Number 2. Let x represent the volume of gasoline in 21-gallon tank. Solution: it is a continuous random variable. Why? Because the amount of gasoline in the tank can be any volume between 0 gallons and 21 gallons, and it cannot be counted. Discrete probability distribution. Lists each possible value the random variable can assume together with its probability. It means it is a list of all possible outcomes of an experiment for a discrete random variable. There are two conditions that must be satisfied. First, the probability of each value of the discrete random variable is between 0 and 1, inclusive. In symbols, the probability of x is less than or equal to 1 and greater than or equal to 0. Second, the sum of all the probabilities is 1. In symbols, the summation of the probability of x is equal to 1. Remember these two conditions because we will be using this in the entire lesson. Okay? Constructing a discrete probability distribution. So how? We have here it's like 4 steps. Okay, so let x be a discrete random variable with possible outcomes x sub 1, x sub 2, and so on, x sub n. Okay, first, make a frequency distribution for the possible outcomes. Second, find the sum of the frequencies. Third, Find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. Fourth, check that each probability is between 0 and 1 inclusive, and that the sum of all the probabilities is 1.
Since you already know how to construct discrete probability distribution, now let's have an example. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 is indicated neither trait. The results are shown. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. Okay, we have here our x, 1, 2, 3, 4, 5 with its corresponding frequency. 24, 33, 42, 30, and 21. So remember the steps of constructing discrete probability distribution. First is make a frequency distribution for the possible outcomes. Okay, Nana. Second, find the sum of the frequencies. So 24 plus 33 plus 42 plus 30 plus 21 is 150. So nanatay summation of frequency, which is 150. Third is to find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. We have here the probability of 1 equal to the frequency of each score over the total of the number of individuals in the study. So we have 24 over 150 is equal to 0.16. Probability of 2 equal to 33 over 150 is equal to 0.22.
The probability of 3 equal to 42 over 150 is equal to 0.28. The probability of 4 equal to 30 over 150 is equal to 0.20. The probability of 5 equal to 21 over 150 is equal to 0.14. Out of those, we can have our discrete probability distribution, which is, ang first row is x and the second row is the probability of x. Let's check if the distribution satisfies the two conditions. Thus, each probability is between 0 and 1 inclusive? Yes. Thus, the sum of the probabilities equals to 1. 0.16 plus 0.22 plus 0.28 plus 0.20 plus 0.14 is equal to 1. So, this means that this distribution is a valid discrete probability distribution. Since the problem is asking us to have the graph of the distribution using a histogram, we have this. Because the width of each bar is 1, the area of each bar is equal to the probability of a particular outcome. Also, the probability of an event corresponds to the sum of the areas of the outcomes included in the event. You can see that the distribution is approximately symmetric. So here, this is the histogram. We can see that the indicated neither trait, which is 3, is the highest. Second is the score of 2, followed by 4, 1, and 5. Verifying a probability distribution. How to verify? Okay, just remember the two conditions of the discrete probability distribution. Verify that the distribution for the 3-day forecast and the number of days of rain is a probability distribution. Thus, each probability is between 0 and 1 inclusive? Yes. Does the sum of all the probabilities equals to 1? Yes. So, both conditions are met, such that the distribution is a probability distribution. Identifying probability distribution. Determine whether each distribution is a probability distribution. Thus, each probability is between 0 and 1? Yes. But, does all the probabilities equal to 1? No. Because the sum of all the probabilities is 1.07, which is greater than 1. And in our second condition, the sum of all the probabilities must equal to 1. So it fails to satisfy the second condition, such that it is not a probability distribution. Number 2. Does each probability is between 0 and 1? No, because there is negative 1 there. It fails the first condition, but it satisfied the second condition. Still, it is not a probability distribution. Mean of a discrete probability distribution. Mean is denoted by mu, and it is determined by finding the summation of x times the probability of x. Each value of x is multiplied by its corresponding probability, and the products are added. For example, the probability distribution for the personality inventory test for passive-aggressive traits is given. Find the mean score. What we're going to do is to multiply the x to the probability of x. For the final step in getting the mean, we are going to add all the products of x and the probability of x. Our mean is equal to 2.94, congruent to 2.9. Let's move on to finding the variance and standard deviation of a discrete probability distribution. Variance is denoted by a lowercase letter sigma squared equal to the summation of the quantity of x minus mu to the power of 2 times the probability of x. While the standard deviation is denoted by a lowercase letter sigma equal to the square root of the summation of the quantity x minus mu to the power of 2 times the probability of x. Let's have an example. The probability distribution for the personality inventory test for passive-aggressive traits is given. Find the variance and standard deviation. We have here the discrete probability distribution table. The first column is the score in the personality inventory test for passive-aggressive traits. And the second column is the probability of x. Since we already know what the mean is, we can now proceed in finding the variance. We have here x minus mu. So our mu is 2.94. In the fourth column, we have the quantity of x minus mu to the power of 2. What we're going to do is to square the difference in the third column. In the fifth column, we are going to multiply the fourth column to the second column. Okay, to finally get our variance, we are going to add all the products of the fourth column and the second column. To finally get the value of variance, we are going to add all the products of the column 4 and column 2. The answer will be 1.6164. And to get the standard deviation, we are just going to get the roots of the variance, denoted by the lowercase letter sigma equal to the square root of 1.6164, congruent to 1.3. Most of the data values differ from the mean by no more than 1.3. Expected value of a discrete random variable. It is equal to the mean of the random variable. Formula E of x equal to mu equal to the summation of x times the probability of x. So our expected value will be the value of mean. That's it for today, and thank you for watching.